Okay, so today we're doing lecture 13, writing polynomials with roots. And I wanted to start off with a note. Okay. If C is a root, also known as a zero, if C is a root of the function f of x, then f of C is equal to 0. So think about what that means. If we know that a number is a root, then we know that the output is always going to be 0, no matter which root we input, right? So when we evaluate this function at C, we're always going to get 0. And that's because when you cross the x-axis, at that point where you cross the x-axis, your y value is always going to be 0, right? So pick any point from the x-axis. Your y value is always going to be 0. And that's why f of C is equal to 0. So what we're going to be doing today, and we're going to be picking up from yesterday, is we're setting the entire polynomial equal to 0 and then solving for x, right? So if C is a root, then f of C is going to be equal to 0, always. And we can also say something else. And x minus C, I'll put that in parentheses, x minus C is a factor of the function f of x. Okay? So x minus C is always going to be a factor, and that is very important. So I'm going to underline that note, and what I'm going to do is I'm going to underline the very important words in red: root, factor. Okay? So do note that another word for root is 0. You can also say x-intercept. Right? All three of these terms mean the same thing: root, 0, x-intercept. Then f of C is equal to 0, and x minus C is going to be a factor of the polynomial. So what I'm going to do is I'm going to draw an arrow from the subtraction sign, and I'm going to say always subtract. That's very important, because x minus C is going to be the factor, not x plus C, x minus C. So what we're going to be doing today is we're going to be subtracting the roots. We're always going to be subtracting the roots. So let's take a look at the problem set, and we'll do a couple problems from there. We'll talk about them, and then we'll take a look at the classwork. Okay? So problem set. All right. Now for each one of these, what you're going to be doing is you're going to write a polynomial. These are the directions. Write a polynomial for the given roots. And I'll always give you 2 roots to start you off. Okay, so number 1 says x equals 5, and x equals 3. So these are going to be my 2 roots, right? Now, we know that 5 and 3 are going to be roots for this polynomial. That means that when you graph the polynomial, it's going to cross the x-axis at +5 and +3. So we know 2 things, right? we know that f of 5 is going to give me a 0. And we also know that f of 3 is going to give me a 0, right? So where am I getting that from? I'm getting that from the f of c equals 0 up here. But we can also say another thing about those two numbers, right? X minus c is always going to be a factor of f of x. So f of x is going to be equal to x minus 5 times x minus 3. So what we're doing here is we're writing out the polynomial f of x, and we're always subtracting the roots, right? So if my root is 5, I'm going to get x minus 5. If my root is 3, then I'm going to get x minus 3. That's also going to be a factor. And now from there, all I have to do is the FOIL method. The FOIL method. So I'm going to write f of x is equal to, and then I do the FOIL from there. So I'm going to switch my color to red, and what I'm going to do is I'm going to underline the f, and the f is going to stand for first. I need to underline first two terms. That's going to be x and x. When I multiply those first two terms, I'm going to get x squared, and now I'm ready for the next letter of FOIL. That would be this O over here. And the O is going to stand for outer or outside, right? So I need to underline in blue the outside terms. Well, if I'm looking on the outer rim or the outside, I'm going to choose x and -3. What's -3 times x? That would be -3x, right? Okay. Change to green. Now I'm going to underline the I. The I stands for inner or inside. So I need to choose the two terms that are on the inside edge of the parentheses. And the inner two terms are going to be -5 and x. Those terms we multiply together. So what's -5 times x? That's going to be -5x. -5x. And then the last thing I'm going to do is I'm going to change to yellow, and I'm going to underline the L because that's going to be the last letter of FOIL. So what does L mean? That stands for last, right? The opposite of first. So I need to choose the last two terms. So those are just going to be the regular numbers, right? I'm going to underline the -5 and the -3. And I'm going to multiply those together. And when I multiply a -5 by a -3, I'm going to get a +15. +15. Okay. All right. So the last thing I really have left to do in the FOIL method is to combine the middle two terms. Usually we combine the middle two terms, but if the two middle terms aren't like terms, then you just go for the like terms, right? I understand that both of these terms end with an x, so I can put them together to get -3x minus 5x is going to be equal to -8x. So I combine those two terms and I bring down the last two terms on the left and the right side. The +15 I bring down, and the x squared I have to bring down. And then just bring down your f of x and you're done. That is going to be your polynomial. So think about it this way. You have this polynomial that you just found. We know that when we evaluate the polynomial at 5 and at 3, I'm always going to get a 0. That means that I'm going to cross the x-axis at 5 and 3. Okay? So what I'm going to do with this is I'm going to hop on over to Desmos, and I want to go ahead and graph this. All right. So I've got f of x is equal to x squared minus 8x plus 15. And I get this green graph over here. Okay. I'm going to change it to black. And what I'm going to do is I'm going to highlight the two roots, right? The two roots are going to be 3, so 3 comma 0, and 5, which is 5 comma 0 as an ordered pair. Notice that the y values for these points are always 0 because that's where the graph is crossing the x-axis. Those are called the x-intercepts, or you can call them the roots, or you can call them the zeros, because all three of those terms are going to mean the same thing for today. Oh yeah, and the vertex is 4, -1, right? That's going to be the lowest point of the graph. Okay, so I'm going to back over to my slide. There we go. And we're going to try some more problems that are just like that. But remember, we're always subtracting c. We're always subtracting those roots. And that's going to become more apparent as we move on to number 2. Okay, so number 2 says they give us two numbers. They give us x equals -2, -2, and x equals -4. Okay, so both of these are whole numbers. They are negative numbers, so that's going to factor into what we write down. These two numbers are where the graph is going to cross the x-axis. So what I need to do is I need to subtract them from x. Subtract them from x. So I'm going to get x minus -2. X minus -4. And hopefully that makes sense. Because I'm always subtracting the numbers, no matter what the numbers may be. Now, because we have a double negative, that means that it's going to be a positive. So I can rewrite this as x plus 2, right? A double negative is going to give me a positive. And I can rewrite the -4 as the x plus 4. X plus 4. So now I've got my two factors that I can FOIL, right? And I forgot my f of x, so I'm going to go back and write that. Okay. So my function is going to be x times x. Those are my first two terms. I get x squared. I do the outer two terms, x and 4. That's going to give me 4x. The inner two terms are 2 and x, so that'll give me 2x. That'll definitely combine with the 4x right here. And then my last two terms are 2 and 4. And if I multiply those, I get 8. Okay. So now what I'm going to do is I'm going to combine my like terms in the middle. Notice that the 4x and the 2x both end with an x, so I can put those together. I'm going to get x squared plus 6x plus 8. And that is my answer. That quadratic polynomial right there. So let's go ahead and graph this and see what it looks like. We're going to graph f of x equals x squared plus 6x plus 8. Okay. So all I'm going to do here is I'm going to change this to a +6. And then I'm going to change this to a +8. There we go. All right, so this is our graph now. Let's see where it crosses the x-axis. -4 and -2. And those were the numbers that we started off with originally, right? -4 and -2. So let's go back and confirm that. Our two roots were -4 and -2. So that's how you find the polynomial that crosses at those x-intercepts. Okay? All right. I'm going to skip 3 because that is just like the one that we just did. We are going to do number 4. Number 4. Okay, number 4 says it gives us two roots, +4 and +4. So notice they give us the same root. It just shows up twice. So 4 and 4 are going to be our roots. Now, if you think about it, how many times is this graph going to actually cross the x-axis? Actually, only once, because these are the same numbers, right? It's going to cross at 4, or you could say 4, 0, because f of 4 is going to be equal to 0, right? That we got that from our note. So what I'm going to do is I'm going to subtract these numbers from x, and I'm always subtracting. So I'm going to have x minus 4 and x minus 4. And let me put my f of x. So f of x equals x minus 4 times x minus 4. If you wanted to, you could rewrite this as x minus 4, the quantity squared. That would be fine, but we're really trying to FOIL it. So we need this expanded form. So the first two terms are x and x. They're going to multiply to give me x squared. I'm going to have my outer two terms, x and -4. That's going to give me minus 4x. And then I'm going to have my inner two terms. Those are going to be -4 and x. So I get the same thing, -4x. And then the last two numbers are -4 and -4. That's going to multiply to give me +16. +16. So now the last thing that I have to do is to combine my 2 + 4x and the minus 4x. And when you put two negative numbers together, you're still going to get a negative number. I get x squared minus 8x plus 16. And I'm done. So that is the polynomial that I'm looking for. Now, the next thing that I want to do is I want to graph this. I want to see what this actually looks like. So what do you think it's going to look like? Because it's going to cross the x-axis at 4. We know that. That's the only place where it crosses. So let's take a look at that. I'm going to do x squared minus 8x. And I think that was plus 16. Yeah. Okay. So we graph it. This is what the graph looks like. Notice where it crosses, +4. So it's not a trick. So if you know that the two numbers are equal to each other for the roots, that means that the graph is only going to cross the x-axis once. And you can actually zoom in and kind of verify for yourself that this thing is only going to cross at one point, which is +4. No matter how close you zoom in, it's still going to cross the x-axis at only one point, this right here. So that's what happens if you have a repeated root. A repeated root. And what you could say about this is, since you know that you can factor this as x minus 4 squared, you can say that root x equals 4 has a multiplicity of 2. Multiplicity? Did I spell that right? Multiplicity 2. Yeah. What that means is the root shows up twice. That's why it has multiplicity 2. And you can tell that by the exponent right here. Okay, so that's number 4. Let's take a look at number 5 on the next slide. Okay, number 5. So for this one, we have 2 roots, x equals -5 and x equals 0. So we know where this graph is going to cross the x-axis at -5 and 0. So I'm going to start off by subtracting these numbers, right? I'm going to have x minus -5, and I'm also going to have x minus 0. X minus 0. So those are going to be my 2 factors. Now we can simplify a little bit, right? Because we have a double negative. So that double negative is going to change to a positive, right? So I get x plus 5. And over here, I have x minus 0. Now, if you're subtracting 0, does that change anything? No. Whether you're adding 0 or subtracting 0 or multiplying by 1 or something like that, you're not really changing anything. So this is just going to be an x. And I close that up. So now what I'm going to do is I'm going to do the distributive property. The distributive property. And what that means is if you have 2 terms being multiplied by 1 term, you're just going to distribute that 1 term to everything on the inside. So I'm going to multiply both of these terms by x, and we're going to see what happens. Okay, so if I multiply x by x, I'm going to get x squared. I bring down the plus, and then if I multiply 5 by x, I'm going to get 5x. And I'm done. That is my polynomial. X squared plus 5x. And let me fill in my f of x. Okay. Let's go ahead and graph this and just confirm it. So what we're going to be looking for is we're going to be looking for where it crosses the x-axis. So let's do x squared plus 5x. So notice for this one, we're not going to have a number at the end. We're just going to have an x squared plus 5x. So I type that in and I zoom out, and here it is. That's our graph. Notice where it crosses the x-axis though. It crosses at 0 and -5. And those were our roots, right? We started off with x equals -5 and x equals 0. All we're doing is we're making the factors out of those. Okay? Let's try number 6. All right, so number 6 says x equals 3 and x equals 1/2. So what I want to start off by doing is subtracting these from x. So I'm going to have f of x is equal to x minus 3. Notice I'm subtracting the 3 and x minus 1/2. I subtract the 1/2. So I'm always subtracting. Now, with one of these factors, we're going to do something very interesting. If you ever have a fraction, what you want to do is you want to take that denominator and put it in front of the x by sliding it in front of the x. That's very important. So whenever you have a fraction like 1/2 or 1/3 or 3/4, you're going to be taking that denominator, the bottom of the fraction, and sliding it in front of the x. So essentially what you get is x minus 3 times 2x minus 1. So all I did was I kept the first factor the same. You can't really do anything with x minus 3, right? But I'm taking the second factor and I'm sliding the bottom of the fraction out in front of the x. So now I have 2x minus 1. And the top of my fraction called the numerator stays the same. Okay? So now what I can do is I can FOIL. I multiply x by 2x to get 2x squared. I multiply x by -1 to get minus 1x. Multiply a -3 by a 2x, you get minus 6x. And -3 times -1 is going to give you a positive 3. Okay, so now that we've done the FOIL method, the last thing that we have to do is put the two middle terms together. Minus 1x minus 6x, that's going to add up to give me minus 7x, or -7x. That is my polynomial. I'm done. So I get 2x squared minus 7x plus 3. That's going to be my answer. Okay, so let's graph this and see what it looks like. I've got 2x squared minus 7x plus 3. So 2x squared minus 7x plus 3. Okay, so we type that in and we're looking at the graph now. Where does it cross the x-axis? It crosses at 2 points, right? 0.5, which is 1/2, and positive 3. So 3 and 1/2 should be our roots, or zeros, or x-intercepts, right? So going back, yeah, we had 1/2 and 3. Okay, so that's what you do with fractions. I want to do another example with fractions. Let's take a look at number 8. Okay, so number 8 says x equals 1/4 or 1/4, and x equals -3/5. And what you'll see is those denominators are actually going to multiply to give me 20. But I'm getting ahead of myself. Let's go ahead and write down f of x. And we're going to subtract these fractions. So we're going to get x minus 1/4. And we're going to get x minus -3/5. So I need to put that number in parentheses because it's already negative, right? So what we're going to do now is we're going to simplify the right side. Now the first factor just stays the same. I have x minus 1/4. I don't really need to do anything to that yet. But this over here, I have a minus minus, and that's going to be a double negative. So I'm going to change that to a positive 3/5. Okay. And now I'm going to take the denominators and slide them in front of the x. I'm going to take the 4 and I'm going to slide it in front of the x. I'm going to take the 5 and I'm going to slide that in front of the x. So when I do that, I get f of x is equal to 4x minus 1 times 5x plus 3. Okay, and now I can do the FOIL method because I've got two binomials now with two terms in each, right? So I can do the FOIL method. All right, so I'm going to underline the first two terms. If I multiply the first two terms, then I'm going to get 20x squared. So see where that 20 comes from? Now let's do the outer two terms. I've got a positive 3 and a positive 4x. They're kind of on the outside, so I'm going to put those together next. That's going to multiply to give me 12x. Now for the inner two terms, -1 times 5x, that's going to give me -5x. And the last two terms are just going to be the numbers. -1 times 3, that's going to be -3. Okay, so now I'm ready to combine my two middle terms. I bring down the 20x squared and the f of x. In the middle, I have 12x minus 5x. That's going to give me 7x. And then the last thing I do, I don't want to forget to bring down the -3, because that's going to be my constant term. Okay. So if I could write these roots as decimals, how would you write these? 1/4, that's 1/4, right? So I could write that as 0.25. And the next root is going to be a negative decimal, I know, because it has a negative sign out in front. How would I write 3/5 as a decimal? Well, I would multiply both sides by 2, so I get 6/10, and that's just 0.6. So when I graph this, I should be able to get those two roots. So let's see what we get. I've got to graph 20x squared plus 7x minus 3. So 20x squared, I think that was plus 7x, and a minus 3. Yeah, there we go. Okay, so when we graph this, we get this very skinny graph, okay? So I'm going to have to kind of zoom in to see where it crosses. That leading coefficient of 20 is going to make the graph very much vertically stretched. But anyways, it's going to cross the x-axis at 1/4 and -3/5 because I get those two decimals, right? 0.25, that's 1/4. And then -0.6, that's -6/10 or -3/5. Same thing. Okay, so that's number 8. That's what you got to do with fractions. You're always sliding the denominator under the x and seeing what happens. Okay, let's do number 9. Number 9. Okay, so number 9 gives us x equals 2i, and x equals -2i. So the first thing I want to say about this is what's with the I? These are actually going to be imaginary numbers. Imaginary numbers, also known as complex numbers, right? You probably learned them as complex numbers. Now, the interesting thing about the imaginary numbers is when they show up as roots, they show up in pairs, and we call those conjugate pairs. Conjugate pairs. Not like pairs from a tree, but like pairs of socks. These things are going to show up in 2s. And it's always going to be a plus bi and a minus bi. Because one thing's for sure, if you conjugate a complex number, you're changing the sign on the I term. So instead of having a positive bi, where b is just a number, you're going to have a negative bi. So this is going to be that conjugate pair. So we say that if z is equal to a plus bi, then we say z bar is equal to a minus bi. Notice the difference. We change the plus to a minus, and then we put a bar above the z. And z is just a variable, right? A and b are just going to be numbers, where I is the imaginary unit. I squared is equal to -1, and I is going to be equal to the square root of -1. So that's how that works. But that's just a basic rundown of imaginary numbers. What we're going to do is we're going to use these roots to figure out what the polynomial is. So what I'm going to do first is I'm going to subtract these numbers. I'm going to subtract these numbers from x. And I'm going to get x minus 2i and x minus a negative 2i. So I use the parentheses for the negative 2i because those negatives are going to cancel. And when I do cancel those, I get a plus. So I'm going to get x plus 2i. And all the while, I've been forgetting my f of x, so I apologize for that. F of x. Yep. Okay. So now that I've got minus 2i and x plus 2i, I can do the FOIL method. I can do the FOIL method now. So let's underline the first two terms, x and x. That's going to give me x squared. The outer two terms, we're going to underline the outer two terms. That would be positive 2i and x. So when I multiply those two together, I'm going to get 2ix. The inner two terms come next. So I'm going to underline the negative 2i and the x. I get minus 2ix. And then the last thing I'm going to do is I'm going to underline the last two terms, right? The negative 2i and the positive 2i. So we're going to take this in steps. So think about it this way. What happens when I multiply negative 2i by a positive 2i? Right? I've got a negative 2i and a positive 2i. When I multiply these, I'm going to get negative 4 from the negative 2 and the positive 2. But what is I times I? That's going to give me I squared. Okay. So I'm going to tack on negative 4i squared. All right. So now let's combine the middle two terms. I've got 2ix and negative 2ix. And the interesting thing about those two middle terms is they actually cancel each other out. So I'm going to cross out the positive 2i and the negative 2i. They cancel each other out. So in the very end, I'm left with just the x squared and the minus 4i squared. So am I done? Not really. Remember that I squared was equal to negative 1. So we can replace this I squared with a negative 1. So if I do that, I get negative 4 times negative 1, which is positive 4. Going back to my problem, I'm going to replace this I squared with a negative 1. So when I do that, I get x squared minus 4 times negative 1. Okay, so we're almost done. All I've got to do now is multiply the negative 4 by the negative 1 to get positive 4. And that's it. That's my polynomial. That's probably that's probably more recognizable than what I had before. Okay, so let's take a look at this and graph it, and let's see where it crosses the x-axis, because it better cross the x-axis at our two roots, right? 2i and negative 2i. So let's take a look at that. I'm going to graph x squared plus 4. X squared plus 4. So I type it in, and where is it? Maybe I should zoom out. There it is, right there. But Does this cross the x-axis? It does not, right? It never crosses the x-axis. So what does that mean? It doesn't have any roots. It doesn't have any x-intercepts. Well, yeah, it doesn't have any x-intercepts because it never crosses the x-axis. But it still has two roots, right? The roots are going to be 2i and negative 2i. But the roots are imaginary. The roots are imaginary. So that's why you don't see this graph crossing the x-axis, because the roots aren't real numbers like you think they would be. They're actually imaginary numbers. So the graph doesn't have to cross the x-axis. Okay? That is number 9. Now, the only other question that has imaginary roots like that is number 10. And I was saving that one for last because it's the hardest. But let's go ahead and try it. Number 10 says x equals 3 plus I and x equals 3 minus I. Okay, so that's number 10. We've got 3 plus I and 3 minus I. Notice that these are conjugates of each other. So these two roots are showing up in conjugate pairs. Okay, so the first thing that we want to do is we want to subtract these numbers from x, and I'll show you how to do it. You basically subtract the 3 plus I in parentheses. So you're going to have a double set of parentheses right there. I also want to subtract the 3 minus I in parentheses. So notice I am subtracting, but I have a lot of stuff going on, so I need to use the parentheses to keep everything straight, at least in my head. So I'm subtracting these two numbers, and what I'm going to do next is I'm actually going to go ahead and put the x with the real number, the minus 3. And I'm going to put the x with the minus 3 right here. So first of all, let me put my f of x down so I don't forget that. What I'm going to do is I'm going to kind of use the associative property to regroup, if that's what I want to say. I want to put the x with the 3. So I'm going to get x minus 3, and that minus sign is going to transfer to the plus I to give me a minus I. Over here, I'm going to put the x with the minus 3. But if I transfer the negative to a minus I, that's going to multiply to give me a positive I, because these two negative signs right here are going to cancel each other. So all I did was I regrouped. So I regrouped x with a, and z equals a plus bi. What I did was I took a, which is the real number, the 3, and I put it with the x, so that now the a isn't with the bi anymore. That's going to be necessary for the next step. Okay, so now that we've regrouped, we can do the FOIL method. We can do the FOIL method now. So let me show you how that works. The first thing I'm going to do is I'm going to underline the first two terms, the x minus 3 and the x minus 3. And when I multiply both of those together, I'm going to get x minus 3 times x minus 3, but I'm going to write it as a square term. Okay. The next letter of FOIL is O, so I'm going to underline the outer two terms. The outer two terms are x minus 3 and positive I. So I get plus I times x minus 3. Good. Okay, the next letter is I, so I'm going to have to change my color to green. And I'm going to underline the inner two terms, the minus I and the x minus 3. Okay, I do that. And then the last thing I'm going to do is I'm going to change my color to yellow, and I'm going to underline the last two terms. Negative I times I is going to give me minus I squared. Negative I squared, because I have two i's being multiplied together. Okay. So what's the next thing that I can do? Well, notice that the two middle terms match up, right? I've got the plus I, the minus I, right? They cancel out. So I'm going to cross these out. I'm going to be left with two terms after that. They are x minus 3 squared. I bring the first term down. The middle two terms are going to get canceled out, and the minus I squared is going to come down. Okay. And the last thing I'm going to do is I'm going to mess with the I squared, because I know that I squared is the same thing as -1, right? So I'm going to keep everything the same. But for the I squared, I'm going to change that to a -1. So I'm actually subtracting a -1. So what does that mean? That actually means I'm adding 1 because of that double negative. Okay. And now what I want to do is I want to simplify this a little bit, because I've got a factor right here, x minus 3, that needs to be squared. So I'm going to get x minus 3 times x minus 3 plus 1. All I did was I expanded that x minus 3 squared into x minus 3 and x minus 3. They are in parentheses, they are close together, so I can do the FOIL method again. I can do the FOIL method once more. So what's x minus 3 times x minus 3? Let me move on over to here. That's going to be x squared minus 3x minus 3x plus 9. And then the plus 1 at the very end has to be added over, or I'm going to get the wrong answer. So once I FOIL that out, I combine my two middle terms, and I can also combine these two numbers as well. I get x squared minus 6x, and then 9 plus 1 is going to give me 10. And there's nothing left I can do, so I'm done. That is my answer. So that's the most complicated one you'll see. And what I want to do is I want to graph this and show you that it never crosses the x-axis, because its roots are 3 plus I and 3 minus I. Those are imaginary numbers, right? So I've got x squared minus 6x minus 6x plus 10. And then this graph right here, it never crosses the x-axis. The lowest that it gets is the y value 1. Y value 1. So it never goes below that. So that means while it doesn't have x-intercepts like you think it might have, it doesn't have x-intercepts, right? But it does have roots. It does have zeros. They are just imaginary numbers. Okay. So I will leave that up there for a little bit and I'll talk about the classwork. The classwork that you're about to do is very much in line with the problem set. If you follow how I did them on here, you'll do fine on it. Just remember that when you do the fractions, you have to slide the denominator. And when you do the imaginary numbers, you've got to be careful with those. Follow them exactly like I did them on here, and you won't go wrong. Okay. And all the numbers on the classwork kind of correspond to the numbers on the problem set. So 1 and 1 are going to be done the same way. 2 and 2 are going to be done the same way. And 10 and 10 are going to be done the same way because they kind of correspond with each other. All right. So what's going to be due on Sunday? You're going to have 2 assignments. There's the finding roots by factoring. Finding roots by factoring or quadratic formula. We did that Monday, and today we did the writing polynomials. The writing polynomials. That's going to be done today. Or at least you can do it today. If you haven't read my notes yet, go ahead and do so. I left out a little bit from the notes that I should have done today, but in interest of time, I'd like to keep it kind of short. But I did forget to mention the fundamental theorem of algebra. The fundamental theorem of algebra. And I'll probably pick up on that on Monday, if I can remember. And I'll talk about it. But basically what it says is if you have this polynomial, f of x, where, you know, you have your standard polynomial, the an minus 1 to the xn minus 1, and you keep on going down to x squared and x and a0, then this polynomial is guaranteed. Guaranteed. Did I spell that right? Guaranteed to have at least one root. At least one root in the complex numbers. In the complex numbers. And I labeled that as capital C. So any polynomial is guaranteed to have at least one root in the complex number system. So we just saw a bunch of problems where it only had imaginary roots, and those imaginary roots are in the complex number system. So, you know, every single polynomial is going to have at least one root in the complex number system. And keep in mind that even if it has real roots, like the first two problems, real roots are complex numbers, right? Real roots are complex numbers. So the theorem still works. And it's been proven. It was proven a long time ago. 1799, Gauss, I think it was. Well, anyways, he proved the fundamental theorem of algebra, and the proof is a little bit complicated for an Algebra 2 class, but he basically said that this polynomial is guaranteed to have at least one root in the complex number system. And in fact, it has at most n roots. Has at most n roots in the complex number system. So at the very most, it's going to have n roots because the highest exponent or the degree of the polynomial, the highest exponent is n, right? So that's why it has at most n roots, but it is guaranteed to have at least one root. And that's fairly simple to prove. Okay, I think that's it. Class dismissed. We'll see you guys next week. If you have any questions about today's lecture, or if you have any questions about the classwork that you needed answered, you can just go ahead and throw them down in the chat box, and I'll spend the last about 5 or 10 minutes just going over those. All right. Have a very mathematical day.